Hello students, our today topic is equipotential surface. The word meaning itself shows that it's a surface where the potential is same at all points on the surface. Let us see what is the concept of this equipotential surface. For that, suppose we have a point charge which is this is a positive charge which is placed in space, and suppose we are taking a point which is at a distance r from the point charge. We are taking a point which is at a distance r from the point charge, where the potential due to this charge at that point is equal to V is equal to 1 by 4 pi epsilon 0 q by distance to the point, 1 by 4 pi epsilon 0 q by r. Let us take another point which is at the same distance from the charge, that is r away from the charge. There also potential will be the same, 1 by 4 pi epsilon 0 q by r. Take another point which is at the same distance from the charge. There also potential will be 1 by 4 pi epsilon 0 q by r. Suppose if the charge is placed in space and we are finding the potential due to this charge which are at the same distance away from the charge. See, as the potential depends on the distance to the point, at all point potential will be same. When the charge is placed in space, if you are collecting all points, the locus of all such points will be a sphere. What is the importance of that sphere is, at every point on that sphere, potential will be same. So, we can call that sphere as an equipotential surface. It is an equipotential surface of this point charge. So, if you are drawing an equipotential surface of a point charge, suppose we are trying to draw one equipotential surface for a point charge. That is, this is a point charge which is placed in space, and we are collecting the locus of all points which are at a distance r away from the point charge. As it is in the space, it is a sphere. So this is a sphere of radius r from the point. This is the point charge which is at the center, and this distance to this point, distance to this equipotential surface is r. So at all point on this equipotential surface, potential will be same. You already see the potential is 1 by 4 pi epsilon 0 q by r. So we can define an equipotential surface as any surface that has same electric potential at every point on it. If you are taking many points on this equipotential surface, the point A and the point B having same potential. Potential at A should be equal to potential at B. So it is known as an equipotential surface. We can draw many equipotential surface for the same charge. Now we drawn an equipotential surface. It's a sphere of radius r. Suppose we are collecting all points which are at a distance r1 away from the point charge. Again, we are getting an equipotential surface of radius r1. Like, we can draw many equipotential surface for the same charge. So, the equipotential surfaces are actually an imaginary surface which can be drawn in an electric field. To picturize an electric field, any surfaces that has same electric potential at every point on it can be called as an equipotential surface. So, an equipotential surface of a point charge is a spherical surface. We can show the equipotential surface due to a point charge like this. We can draw many equipotential surface for the point charge. This is a positive charge Q, and we are drawing one of the equipotential surface for it. This is one equipotential surface for the charge, and we can draw another equipotential surface for the charge like this. This is the second equipotential surface. We can draw many equipotential surface for the same charge like this. This is the another equipotential surface. And see, for this equipotential surface, suppose we are taking the 2 points on this equipotential surface. A and B are the 2 points on the same equipotential surface. And we already seen potential at A and potential at B will be same. That is, the same potential is at A and B. What is the potential difference between these 2 points is 0. When you are moving as test charge from A to B, we can say what is the work required for the process is work is equal to, usually we are taking what? Charge into potential difference. Charge into potential difference. What is charge? Charge is Q0. Charge is Q0 and the potential difference is 0. So it is equal to what? 0. What else means? It shows that no work is done in moving a test charge over an equipotential surface. No work is done in moving a test charge over an equipotential surface, as the potential at every point on the surface is same. No work is done in moving a test charge over an equipotential surface. It's a very important point. It's a very important properties of equipotential surface. Got it? Now, in the same diagram, we can show the electric field lines which are originating from the source charge. Suppose I am drawing the electric field lines from this charge. These are the sum of the electric field lines which are directed radially outward from the source charge. I am drawing, these are the electric field lines which are originating from the source charge and which is directed away from the charge as it is positive charge. You will see that at every point on the equipotential surface, the electric field lines are normal to it. That's angle between the electric field line and point on the equipotential surface is 90 degree. So we can say always the electric field lines are perpendicular to the equipotential surface. The electric field lines are perpendicular to the equipotential surface. See what happened if the electric field lines are not perpendicular. Suppose the electric field having a non-zero component like this way. If this is the direction of electric field lines here. Now this electric field having a non-zero component along this surface. Is it? Along this surface, the electric field having a non-zero component. If you are moving a charge from one point to other point through this surface, work has to be done against this electric field. But actually, for an equipotential surface, if it is equipotential, no work is required. So, never electric field having a component along the surface. That is why always equipotential surface or electric field must be perpendicular to the equipotential surface. It having no component like this, it have only a component that is perpendicular to the direction of, it is perpendicular to the what? Equipotential surface. That's the second properties of equipotential surface. That is always electric field is normal to the equipotential surface. Normal means perpendicular to the equipotential surface. We see two property. One is no work is done in moving a test charge over an equipotential surface. The second point is electric field is always normal to the equipotential surface. Okay. Now you may be seen that we cannot draw an equipotential surface like this way. If I am drawing another equipotential surface, never I can draw like this, an equipotential surface. Here if I am drawing like this way, here two equipotential surfaces are intersect each other or they cross each other. That's it. It is impossible. Never, no equipotential surface can intersect each other. It's another important property of equipotential surface. If two equipotential surfaces intersect each other, there are two values of potential. That's it. There are two directions for electric field at that point. Or there are two values for electric potential, which is impossible. As it is an equipotential surface, it can only have one value of potential and it can have only one value of electric field. So, never two equipotential surface intersect each other. That is the third point. No equipotential surface can intersect each other. Okay. Now see, the another properties of equipotential surface is that equipotential surfaces are, when you are drawing the equipotential surface for a point charge, the first surface I drawn here, this is the first equipotential surface due to this point charge. And this is the second equipotential surface. We can draw many equipotential surface like this way. Where I drawn, this is the second equipotential surface. And see that the distance between the equipotential surface should increases when you are moving away from the charge. That is, the equipotential surfaces are closer in the region of stronger field. We know that very close to the point charge, the electric field is strong, and so the distance or separation between the equipotential surface will be small. When you are moving away from the source charge, electric field decreases. When the intensity of electric field decreases, the distance between the equipotential surface are also increases. That is the fourth point. The equipotential surfaces are closer in the region of strong field and further apart in the region where the field is weak. Good. These are the properties of equipotential surface. Now let us see the equipotential surface of different charge and charge distributions. Suppose this is a point charge and we draw the equipotential surface due to this point charge. This point charge, this is a positive point charge, and these are the sum of the equipotential surface due to this point charge. I draw many equipotential surface for the point charge, and these are the electric field lines due to this point charge. This is equipotential surface for a point charge. Now suppose we have a uniform electric field like this. This is a uniform electric field. This is a uniform electric field. And if you are drawing equipotential surface for this uniform electric field line, this is a plane which is perpendicular to the electric field lines. This is one of the equipotential surface for this electric field. We can draw a number of equipotential surface like this. You see that this is the direction of electric field lines or electric field which is perpendicular to what? This is perpendicular to our equipotential surface. Equipotential surface due to a uniform electric field. For uniform electric field equipotential surface. This is equipotential surface for a point charge, and this is electric field, equipotential surface for a uniform electric field. See, similarly, I shown the equipotential surface of a dipole. equal and opposite charge. This is equipotential surface of an electric dipole or equipotential surface of a equal and opposite charges. See here the positive charge is here, this is positive charge and this negative charge. And here the field is somewhat stronger between the line joining of this charge. In this region electric field is somewhat stronger than this side, is it? So here the separation between the separation between the surfaces, equipotential surface is less. Here the separation between the equipotential surface is more. And here I shown some of the electric field lines due to the charge distribution of dipole. These are the black lines shows the electric field lines, and this blue lines shows that the equipotential surface. These are the sum of the equipotential surface due to a electric dipole, equal and the opposite charges. Another diagram, this is an equipotential surfaces of equal positive charge. Here two positive charges are shown here, plus Q and another plus Q, similar charges plus Q. And these lines shows the electric field lines due to this charges, electric field lines of the black lines. And here the blue lines indicate the equipotential surface. We know that comparing these 2 points, here the strength of electric field is greater than the strength of electric field in between the charges. That is why the separation between the equipotential surface is more here. In this region, the separation between the equipotential surface is more, where in this region electric field is strong and the separation between the equipotential surface is less. In this way, we can draw the equipotential surface for the various charges. Remember, an equipotential surface is an imaginary surface which can drawn in an electric field, and it's a surface that has same electric potential at every point. And remember these properties due to equipotential surface. And draw equipotential surfaces. Try to draw the diagram of equipotential surface due to a point charge, equipotential surface due to a uniform electric field, equipotential surface due to a dipole, and equipotential surface due to like charges. Okay.